All right, so before we talk about tangent, let's just quickly review, since it's been a week since y'all thought about anything. Here are my two parent functions for trig functions we've talked about so far. Which one is this? And this is cosine, okay? Both of these are sinusoidal functions, right? Because I could write the equations for either one of them is either sine or cosine. They're just horizontal shifts of each other. What is the period for the parent function? One cycle takes how many units? 2 pi. It's one rotation around the circle. So 2 pi units is your period for sine and cosine. We've got to know that because we're about to get into tangent, and if we don't understand sine and cosine, it's going to make tangent even more difficult. These are also periodic functions because they repeat, right? This is one period, and it's basically just like move it over and stamp it again, and it could just keep going and going and going. So all of our trig functions are periodic. They are not all sinusoidal. These are the only two that are sinusoidal, okay? But still periodic because we still have the repeats, all right? All right, so let's look at tangent. This is going on page 93 when we're done. So when we first looked at tangent, well, when we first looked at it in 3.2, not when we very first looked at it, but when we first looked at it in 3.2, we defined the tangent of the angle as the slope of the terminal ray. And that's what some of us were still getting a little mixed up or not paying attention to, even when you took the test before spring break. Or is the ratio of the angle's sine and cosine values. So that was the first thing we learned. But then I said, we've got to tie this to slope. Well, we know that we've got y equals mx plus b, right? And here's my terminal ray. Oh my goodness. Here's my terminal ray. So that terminal ray lives inside of this line right here. That line goes through the origin, which means your y-intercept is 0. So basically, it's just y equals mx. And then if I want to solve for the slope, I divide both sides by x and get y over x equals the slope. Well, in a unit circle, y over x is sine over cosine. That's what it says right here. Tangent is sine over cosine. Tangent is y over x. Tangent is the slope. And as you look through this is quadrant 1, and this is quadrant 3. That is a positive slope, and that is why tangent is positive in quadrants 1 and 3, and it is negative in 2 and 4. Okay, so don't forget. I think we all pretty much know it's sine over cosine at this point, y over x, but don't forget that it's also the slope. Okay, we're good? All right. So we are going to develop the graph. It says, let's look at the slope of the terminal ray is our angle. So this theta disappeared, so put a theta back in there. Theta increases from 0 to pi halves. All right, so here, this is at, my angle is 0, and it says it right there, but it's really tiny, but theta equals 0. So then the slope, which is the tangent of theta, this is a horizontal line. What is the slope of a horizontal line? Or what is the tangent of 0? 0, okay? The tangent of 0 is 0. The slope of a horizontal line is 0. They're one and the same, okay? So this here, we'll say that the angle here is at pi 6. So what is the tangent of pi 6? Square root of 3 over 3, yes. And then here, this would be pi 4ths. What is the tangent of pi 4ths? 1. It's the easy one, right? And then we've got pi 3rds. What is the tangent of pi 3rds? Square root of 3. Okay. And then we have this angle, which we don't know what it is, but the angle is approaching, so theta is approaching pi halves. Okay, that's what's happening there. Theta is getting close to pi halves. Look at your tangent values. We started at 0, square root of 3 over 3, 1, square root of 3. How would you describe what's happening to those? They're getting bigger, right? If I start at 0, square root of 3 over 3, 1, they're increasing. Would you agree with that? So it's increasing. It's going to keep on increasing. So that means then I look at tangent of theta, see what it is approaching. It's going to keep on increasing, increasing, and then we get a vertical line. What is the tangent value of pi halves? Undefined. And it's undefined because we are approaching infinity. It's getting bigger and bigger and bigger. Okay? So what all this means is this. When theta equals 0, right here, the slope of the terminal ray is 0. That's from our first circle. As theta increases, the slope also increases. So as theta approaches pi halves, the slopes, which are our tangent values, get steeper and steeper, or more and more positive. Okay? So then when we actually make it there, and we are right here at pi halves, when we make it to pi halves, it is now vertical, and the slope of a vertical line is what? Undefined. Okay. So when we say that the slope is undefined, it is because it is infinite. So what this says is the limit as tangent approaches, as theta approaches pi halves from the left. Now, if you look up here, it looks like we're approaching from the right? But we're not talking about on the circle. I'm talking about on a number line. On a number line, I'd have 0, pi halves, pi, right? So if I'm going from 0 to pi halves, I'm approaching pi halves from the left. You see how that works? So don't think about on the circle. It's on a number line. As I approach theta, or as I approach pi halves from the left, my tangent values are getting bigger and bigger and bigger. That's why I'm approaching positive infinity. Okay? Everybody good so far? All right, now tell me what you know about tangent in the second quadrant. It's what? It's negative, exactly. So tangent is negative in the second quadrant. So let's start with this one, which would be my pi thirds angle. What's your second quadrant pi thirds angle? 2 pi over 3. Good, 2 pi thirds. All right, so then if I know that tangent is negative, the tangent value would be negative what? What's the tangent of pi thirds? Square root of 3. Okay. Then this would be what's my second quadrant pi fourths angle? 3 pi fourths, very good. 3 pi fourths. Again, we're in the second quadrant. We know tangent is negative. It's negative what? 1. Okay. Then this will be my pi 6. What is my second quadrant pi 6 angle? 5 pi 6. Very good. And so then this tangent value is negative what? Square root of 3 over 3. Good. Then we make it all the way over here to pi. What is the tangent of pi? 0. Okay. So this time when we start so we were going this way, right? So let me remind you, we were going this way. We started at 0 and we approached positive infinity. Then we're starting at a negative number and approaching 0, which means I'm increasing here again, right? But if I was to think about going in this direction, I'd have a 0 and getting more negative. So when I'm coming this way, I'm actually approaching negative infinity. So the limit I would write here, again, we're thinking on a number line, 0, pi halves, pi. If I'm going from pi to pi halves, going this way, I'm approaching from the right, right? So I would say the limit as theta approaches pi halves from the right of tangent of theta, I'm at 0. I'm getting more and more negative. So I'm approaching negative infinity. Okay, and I'm going to make all that make a little bit more sense in just a minute. Okay, questions at this point, though? You understand where all this is coming from at this point? And then I'll put it all together in a second. Okay. All righty. Let's flip it over. And we're going to come back to that. We're going to do the same kind of thing here, except the pictures aren't quite as accurate. So we're just going to skip over some of these. But this time we're going from pi to 3 pi halves. So we're going to make this 7 pi 6. Now we're in the third quadrant. What do we know about tangent in the third quadrant? It's positive. So this would be a positive what? Square root of 3 over 3. Good. And then this one will say that this is 4 pi thirds. So what's the tangent of 4 pi thirds? Square root of 3. We're skipping some of these because they're not really. And then once we get here, we are at 3 pi halves. What's the tangent of 3 pi halves? Undefined. Okay, so again, as I go from pi to 3 pi halves, as I'm going this way, I start off with a value of 0, increase to infinity, which is what gets me undefined there. Okay, now we're about to take this and put this on an xy axis like we did for sine and cosine, right? Kind of taking it. This was less on the unit circle than sine and cosine really was for you, but we're still thinking about the unit circle. Now remember, when I ask you about quadrants, we're talking about these. I don't care about these quadrants down here. But we have some undefined values. When we graph things, what's one way that we can show on the graph that something is undefined? Like I can't graph anything at 2. 2 is undefined. What's one way I can show that? Okay, I could have a hole, right? I could have a hole like we did with rationals. Sometimes there's a hole in there because you had to divide things out, right? That's one way to show that that's undefined. We just sort of took it out. What's another way? What else can make my graph discontinuous? Think about if I was going to draw, don't draw this because I'm going to erase it. But if I was going to draw something like, well, if I can draw sine or cosine, that's a continuous function, right? If I had a hole somewhere, then it's not continuous and I have to skip over that. What else? Say it. What else would make it discontinuous?
I don't know.
Yeah, with what? What is that? What kind of line? Vertical asymptote. Thank you very much. Whew, that was rough. Vertical asymptote, right? Were some of us thinking that but too afraid to say it? Okay. So those remember, for your discontinuity, let's back it up just a second. And so I could have a hole, that means it's discontinuous. I could have an asymptote, well, it doesn't even look like that. I could have an asymptote, or it could like jump, right? There's jump discontinuity. But those are your 3 types of discontinuity. But what's going to end up here, because of what we have, it says each time that a terminal ray is vertical, the slopes are undefined, so they approach positive or negative infinity. When we graph the tangent functions, that means we will see vertical asymptotes. And remember, if there's a discussion between what's the difference between an asymptote and an asymptote, it's that an asymptote doesn't exist, right? Okay, so don't forget that. Don't get confused. Asymptotes. All right, so let's think about that. I've got my unit circle. And when we're talking about tangent values, I know the tangent value here is 0, 0, and these are undefined. You agree with that? Right? That's something we know. So that means that when I'm going around the unit circle, when's the first time tangent is undefined? What's this angle? Pi halves. So at pi halves, I have a vertical asymptote. When's the next time I'd have a vertical asymptote? 3 pi halves, okay? And then if I started here and went clockwise, that would be at negative pi halves. And then again at negative 3 pi halves. Okay? So already you can tell this isn't going to look anything like sine and cosine. Right? All right, so then when is the first time that my tangent value is 0? That's 0. So I can put a point right there. When's the next time tangent is 0? At pi. And then what's the tangent of 2 pi? 0. And then if I went the other way, that'd be negative pi and negative 2 pi. So remember, this is not sinusoidal, but it is periodic. So there is a pattern there. Once you get one little section of it done, you can repeat it forever, right? But I need a little bit more than that. And so I want to look at pi fourths. What is the tangent of pi fourths? 1, okay? Right there. And that came from the first quadrant, right? So then 3 pi fourths is right here in the second quadrant. And in the second quadrant, tangent is what? Negative. And so that means at 3 pi fourths, I'm going to redo that point there. At 3 pi fourths, tangent is negative 1. I just tried to redo it and put it right back in the same spot. And then I get to the third quadrant. That's my 5 pi fourths. What's the tangent value there? Positive 1. And then when I get into the fourth quadrant, it's negative 1 again. Y'all see that? And then you can just put in the rest of the points because you should be able to see a pattern by now. Like so. All right. So now when I try to connect these things, now horizontal asymptotes I could cross an infinite amount of times, but you cannot cross vertical asymptotes. But let's think about what we said right back here. When we did this right here. As theta approaches pi halves from the left, tangent is approaching infinity. So when I look back over here, as I am approaching pi halves, which is right there, from the left, tangent is approaching infinity, so it would look something like that. Does that make sense? Because that's what asymptotes do, right? You don't stop right at them. They're there because we're going to positive infinity. Now, as weird as this seemed here, when I said when we're going this way, it's getting bigger, so we're approaching infinity. When we're going this way, we're approaching negative infinity, right? If I'm going from, so pi halves from the right, I'm approaching negative infinity. That's what's going to happen right here. As I approach pi halves from the right, I'm going to negative infinity, like so, except actually go through the point. But do you see how that works? And so what's really happening here is you have these little things that kind of look like a bunch of cubic functions, but they're not, because cubic functions have a domain of all real numbers, but it has the point of inflection, and it definitely looks cubic-like. Okay? And they're easier to draw when you draw the whole thing instead of like half on some of those I was trying to do, which would probably look better if I did them the other way. But there's your tangent function, or a bunch of cycles of the tangent function. Now, when we draw the parent function, I think it's good to stay consistent because this is just the third of 6 we have to know, all right? So it's better to be consistent. We're starting at 0 on all of them. Even though this looks like a cubic function, I think, like I said, consistency is the key here. So the way I want you to draw a parent function for tangent is like this. Okay, like the first 2 things we did, instead of like one complete curve. There's a reason for that, I promise. It'll make more sense after we understand some more things. But the main part right here is just staying consistent. Because then we have 5 pieces, just like we had 5 points on the others. I know that these right here are on the x-axis as a parent function. Halfway between the 2, so I've got this, and then halfway between the 2, I have this asymptote. And then halfway between these 2, I go up to 1. Halfway between these 2, I go down to negative 1. So this, let me see if I can do this like I want. So this part here is like your parent function, okay? Including the, I guess I could have included this. All right, that's where that's coming from. It's just that part of it. Because then here, it just starts over again. Would you agree with that? You see how it just starts over and the same thing happens? So that's one cycle that I highlighted in purple. So if I start at 0 and I end here, what is the period for the parent function of tangent? Pi. The period is pi. It is not 2 pi. It is pi for sine and cosine. I'm sorry, it is 2 pi for sine and cosine. It is pi for tangent. So clearly the graph looks way different. That's one major difference. It is still periodic, but the period is different. And that is probably one of the biggest things that gets messed up and confused. Okay, so make sure you remember that that tangent is different. All right, everybody good so far? What questions you got? Okay. So let's talk about transformations before I give you your second sheet of paper. We've been doing transformations forever. You know what they look like. You know what the letters do. So with sine and cosine, A had another special name. What was the A for sine and cosine? What does it stand for? It's a word that starts with A. Amplitude. Yes, thank you. It's the amplitude. Tangent does not have an amplitude because the amplitude is the distance from the midline to a min or a max. And there is no minimum or maximum because we're going to infinities. So it's still the A, it's still a stretch, still does the same thing. It's just not called the amplitude. And then period, you basically do it the same way, except this is pi instead of 2 pi. So don't forget that. And then if I need B, that would be pi divided by the period. Okay, Melvin, you getting all this? Then we still have a horizontal shift of C or negative C and a vertical translation for D. With your vertical translation of sine and cosine came the midline. There's also no midline here because there's no middle, but where the midline would be is where the point of inflection is. And so it's still pretty easy to find and can help you with that value. And I'll show you as we go through that stuff. Okay. What questions do you have at this point? All right, let me give you your other sheet of paper. I didn't want you to pick both of them up because I didn't want you to see this graph. I'm sure you've probably seen a tangent graph before, but I would imagine most of you didn't know it was a tangent graph you were looking at. So, or maybe it is. That might be an extra one. I feel like I've got too many. I think I gave a couple of y'all tables a little extras just because they were stuck together. Just leave them on your table. Yeah. Come on, Jenny, sit up. All right, so this is also going on page 93 when we're done. So here's example 1. You are not going to have to graph it yourself on the exam. Okay, it's just a matter of understanding how this stuff works. So this tells me a portion of function f is shown above, and it can be written like this. So it flat out tells me it's tangent, which is good because tangent and cotangent look very similar, and I would have to look at things differently if I didn't know for sure this was tangent. And I'm looking for A, B, and D. Okay. And there is no horizontal shift because they didn't put C in here. So there is no C, which means I know I'm not shifting left or right. So I'm going to look for D first. And so here are my points of inflection right there. They are on the x-axis, which means I did not shift this up or down at all. So D is 0. Okay. Then when I want to look for A, so remember, here's my little parent function. I would highly suggest you draw this for every single question. That way you don't have any question about what's what. Like you won't even have to think about it anymore because like I said, we have 3 more to go and the last 3 look crazy confusing. They're not necessarily, but they look bad. I'm going to put some extra stuff on this one just to remind you that we're looking to go to 1 and -1 here. So when I look at my graph over here, I've got the beginning and the end. So this would be the beginning and the end of the period. Halfway in between the two is where my asymptote goes. And then halfway between these two is where I would go up to 1 or down to -1, unless there was a stretch. So halfway between this point and the asymptote, I go up to 1. So that tells me that the absolute value of A is definitely 1, and A is a positive 1. If I had to go down first, then it would be negative because of the reflection. okay? So I'm looking at halfway between these two, I go up to 1. So I didn't stretch at all. A is 1. And then since I already found the beginning and the end, I can see that the period here is pi halves. But that's not B. That's what gets me B, right? So to find B, what goes in the numerator for tangent? Pi. So it's pi over pi halves. You go ahead and work that out. And this is one of those things where I would suggest that you write it out. Don't just stare at it. I don't care how smart you are, because this is where I see people that I know you know how to do it right. I know you do, but then use the wrong number because you're looking at it and trying to do it quickly and you mess something up. So remember that this would be pi times 2 over pi. I can put that over 1. So that means B is 2. Okay? Don't mess that up. It is so easy to mess up, even when you know what you're doing. Okay? What questions do you have? So the processes are they're the same as you do for sine and cosine. The graph is just a little different, and you just have to know some values and you'll be okay. All right, any questions? All right, so let's look at example 2. I know it just asks me for the period, but we're going to find everything we can. So in this equation, what is A? 4. What is B? 2. What is C? Is there a C value? No, then C is 0. Because you could be asked for a value that's not there, it just makes it 0. Because we're not shifting left or right, okay? And then D is what? 5. Okay, so my vertical dilation, my horizontal dilation, my horizontal translation, and my vertical translation. Well, when I'm looking for the period, we know that that relates to B. So to find the period, what goes on top for tangent? Pi. It's pi divided by B, which is 2. And then I simplify, which I can't, so my answer is pi halves. Okay. What questions you got? Okay. So this says, let G be this function. Which of the following gives the vertical asymptotes of the graph G? Okay, so let's figure out what we know here so far. And you don't always have to start with the asymptotes. Like, start with what we know. Let's find all our values here. What is A? 2. B is 1/3. C is 0. D is -1. Okay, so think about your vertical asymptotes. If I have a vertical dilation, I can stretch and compress vertically all day long. That doesn't affect my vertical asymptotes. I can shift it up and down all day long. Doesn't affect my vertical asymptotes. These are the two things that affect your vertical asymptotes. Shifting it left and right, or stretching it or compressing it horizontally. I don't have a shift left or right, so I'm really only interested in the period, like the horizontal dilation. So let's graph our little parent function. And now I know that this gets shifted and stretched, but I don't even care because it's only the horizontal stuff that affects anything. But I would like to know what the period actually is, right? So I would take, what goes in the numerator? Pi divided by 1/3. And what is pi divided by 1/3? 3 pi. Okay, so my period is 3 pi. Right? For each period, so remember it's periodic, that's just basically like just move over, stamp it again, move over, stamp it again. There's one asymptote there right in the middle of it. So my first asymptote, because I know this does not get shifted left or right, I know it goes up and down and it stretches, but again, that doesn't matter for right now. But my first asymptote is halfway between 0 and 3 pi, which makes this right here at 3 pi halves. And then whatever the period is, that's how far apart your asymptotes are. So at this point, there's two different ways to find my answer. First of all, there's only one of them that even starts at 3 pi halves, and it's this one. But even if this one also said 3 pi halves, it says plus pi k. So that would mean every pi units, I'd repeat an asymptote, and that's not happening. My asymptotes are repeating the length of the period. This is where I start, and then it happens every 3 pi after that and every 3 pi before it. And that's what gives me C. Okay? Sketch a figure, label some stuff. Don't be lazy. Don't think you can just stare at this and make sense of this stuff, because that's where it's going to get all mixed up in your brain. Okay? What questions you got? All right. So let's look at this one. So this one I'm looking for the actual equation. So the first thing I like to look at the midline first for sine and cosine. So my pretend midline that's not really a midline is where all the points of inflection are. So those points of inflection occur at y equals -2. So are there any of these that I can eliminate? Which ones? B and D, right? Because they got shifted down 2. So I can eliminate those 2. Then I'm looking for the period. Remember, this is my parent function. So I'm looking at, I start here, it goes up, got my asymptote, and goes like this. So I'm starting here and ending here. The period here is 2 pi. For my equation, I need B. What goes in the numerator to look for that? Pi, and then 2 pi in the denominator. So that means that B is equal to what? 1/2. And my answer is A. Okay? What questions you got? We good? Yes? All right. Now, we should be experts at this by now. We're going to find the values of these expressions. What's the tangent of pi 6? Square root of 3 over 3. Pi 4ths. 1. Pi 3rds. Square root of 3. All right, 5 pi 6. What quadrant is that in? Second. And in the second quadrant, tangent is what? Negative. So this is a negative what? Square root of 3 over 3. Beautiful. 4 pi 3rds. What quadrant are we in? Third. In the third quadrant, tangent is positive. So this answer is square root of 3. Good. 7 pi 4ths. What quadrant are we in? Fourth. And in the fourth quadrant, tangent is negative. So this is a -1 for pi 4ths. All right. Then 3 pi halves. That's quadrantal, right? And it's down here. That is a vertical line. What's the slope of a vertical line? Undefined. Pi is right here. That's on a horizontal line. What's the slope of a horizontal line? 0. Pi halves right here on a vertical line. What's the slope of a vertical line? Undefined. Very good. Okay. You need to practice this. When I give you your assignment, do not just stick it in your binder and never look at it again. Practice it while it is fresh on your mind.